Protein aggregation causing fatal diseases. What is the reason for abnormal protein aggregation in our body? Technology closest to the truth. ProWave, which was developed by the Sugyeong Women's University research team in Korea, led by Professor Shi-hyun Ham, answers the questions.
So far, predicting protein aggregation propensities have been difficult. The reason is simple. In our body, proteins are surrounded by water all the time. But how to calculate these protein-water interactions accurately is not trivial. Since previously, people have overlooked the fact that the protein in our body always interacts with water, people couldn't calculate the thermodynamic properties of the proteins accurately. To understand proteins' behavior, one needs to properly account the interactions between polar proteins and water, which has a dipole moment. Fluctuating thermodynamics for biomolecular world is the technology that predicts biomolecular structures and functions in our body by analyzing the interactions between biomolecules and water by computer simulations and statistical thermodynamics. ProWave is one of the applications of this fluctuating thermodynamics.
Professor Ham and her team introduced a concept of solvation-free energy for predicting protein aggregation propensities for the first time. With the solvation-free energy, quantifying hydrophilic and hydrophobic regions of proteins brought a turning point in protein research and design. Unlike the previous models, which treat solvent water implicitly to reduce a huge computational load, fluctuating thermodynamics treat water molecules explicitly, achieving accuracy as well as speed through an innovative algorithm. Fluctuating thermodynamics offers a comprehensive picture of diverse biological processes by encoding thermodynamic hotspots, and showed a far higher accuracy than any existing applications of predicting protein aggregation propensities upon mutations. How to increase protein solubility? It is difficult if you consider protein net charge only. Fluctuating thermodynamics, however, provides residual solvation-free energy and water distribution around them. Here are two polar proteins, A-beta-42 and acyl phosphatase. Both are aggregation prone in a native condition, yet how to improve their solubility are different in those two cases according to the fluctuating thermodynamics. Around A-beta-42, whose total charge is -3, water molecules position their positive hydrogens towards the protein. By contrast, around acyl phosphatase, protein whose total charge is +5, water molecules position their negative oxygens towards the protein. What is noteworthy is that some regions of the protein exhibit electrostatic repulsion to the reoriented water molecules. These regions tend to aggregate to avoid repulsions by water molecules around them. Fluctuating thermodynamics framework produces surprisingly consistent results with the actual experimental data. Now we understand how to control protein aggregation behavior and offer novel design principles for producing aggregation-resistant proteins.
In the future, fluctuating thermodynamics will contribute greatly to the treatment of incurable diseases and the development of medicine. There are many cases where a vaccine that has been developed with difficulty fails as it aggregates when injected into a living body. If they had used fluctuating thermodynamics from the early stage of the development, this trial and error can be reduced significantly. Recently, our fluctuating thermodynamics technique has been used to develop monoclonal antibody at the Boehringer Ingelheim in Germany by finding out hotspots and by designing less aggregation-prone mutants. This is one of the examples of our technique to be used to design less aggregation-prone proteins.
Fluctuating thermodynamics has a wide range of applications in biotechnology and biotherapeutics. Like identifying the cause of amyloidosis related to kidney dialysis, screening new drug candidates to bind beta-amyloid oligomers as the diagnosis of Alzheimer's disease, activating p53 peptide through the development of cyclized helix-loop-helix peptide that binds to MDM2 in cancer cells, developing OPT3 peptide with high binding affinity to immunoglobulin A. Fluctuating thermodynamics is an innovative science creating a new paradigm in biology and has made an impact and benefit in bioindustry. SNO processes to compute fluctuating thermodynamics algorithms. It performs 1,583 trillion floating point calculations per second. SNO now provides ProWave Internet services. Although the web version of ProWave has limited functions compared to the software version, it is enough to compute solvation-free energy and simulate proteins. The ProWave web application is easy to use. If you upload the protein PDB and click the Execute button, ProWave provides the solvation-free energy calculation results in a few seconds. Another key to the mysteries of life. ProWave. Beyond just academic achievements, fluctuating thermodynamics will be a game changer and make a big impact in bioscience.